Today we're going to be talking about overclocking. And what overclocking is, to give you a brief introduction, basically it's just increasing the speed of certain components in your computer to achieve greater performance. And so we're going to be talking about how overclocking applies to workstation grade computers. So Damian, okay, so you're responsible for like our system optimization and stuff, and of course like one of the steps in there is overclocking. So like what exactly is your background like with overclocking?
So I probably started tinkering with computers when I was about maybe 10 years old. My dad brought our first computer home, and yeah, from there I remember him, before leaving for work, leaving me the DOS command prompt sort of things that I needed to type in to get my games to start working. And I guess it all kind of went from there. Good few years later, I remember us getting Pentium 3.
Okay.
One of those Mesa Pentium 3s with the sort of the fronts that sort of slope back.
Were those beige, or what color was that?
Yeah, sort of a beigey or white.
Yeah,
with a sort of a blue handle on the top.
Oh, okay.
And that was a 1 gigahertz Pentium 3. So,
wow.
Yeah. Graphics card wise, it had a NVIDIA TNT2.
Okay.
I remember having to overclock that and back in those days put an ice pack on it to keep it cool so that I could actually play Call of Duty at reasonable frames. Wouldn't try it on anyone else's PC, but yeah, it was a good experiment.
Okay, so that was like back in those days then, and I mean, of course, like it's been several generations. How has stuff changed? Do you think it's like any easier to overclock?
The basic concept's the same. I mean, you've got this constant battle between thermals and setting the correct voltages. The higher you make the voltages go, higher the thermals. But you need voltage to increase the frequency of the CPU up to a certain point, obviously. So yeah, the basic concepts are the same. The way you go about doing it varied as well. Back then we used to overclock, depending on what CPU it was, we used to overclock the front, what was called the front side bus back then, similar to BCLK overclocking.
Yeah.
12th gen CPUs with the advent of the big core, little core, the performance cores, efficiency cores.
I was going to ask about that, yeah.
Yeah, that adds a bit of an extra element in. But at the same time, it helps us better understand our customers' workflow, and it gives us more scope to finely tune the PC to their specific needs. So depending on the software they're using, would it be using the efficiency cores as well? If not, then we start focusing more on overclocking performance cores, or sometimes it's a balance of both. So it gives us more freedom at the end of the day.
So they have those big core and little core situations over there. Firstly, what's the difference in how they handle overclocking? And secondly, does one help with single core stuff more and multi-core? What's the relationship there?
So they overclock pretty much the same way. Depending on what you're doing, like I said, sometimes you even disable the efficiency cores. You work only with the performance cores, but they work the same way with regards to a balance between frequency, thermals, and voltages. There's obviously quite a bit else involved, but those are the main aspects to consider.
Okay, so moving on to how overclocking affects workstations. Firstly, why isn't this something we hear about very often? Why do you think it's a good idea?
So overclocking is normally something that gamers do to increase the frames per second that they get in their games. And most people sort of shy away from it in a sort of workstation environment, work environment where uptime and system stability is the main focus. But what we found is that it allows you to take chips that for the most part are made to be overclocked when given the right environment, should I say, like having a better CPU cooler. All you're really doing is you're optimizing the performance of the CPU. You're basically getting the most value for your money. You're getting it to run as quickly as it can, while still maintaining low temperatures, high reliability, high stability, etc.
So you also mentioned then coolers and things. So yeah, how does the hardware...
So this, and we'll probably put it into some B-roll, but this is the standard cooler that you'd get with a run-of-the-mill consumer-grade Intel CPU. As you can see, it's And this is probably one of the better designs. A year or two ago, they were even worse than this. And this will keep the CPU relatively cool at lower speeds. So, you know, I wouldn't want to run a K CPU with this because they don't even come with the K CPUs. You need to buy your own cooler. Quite a few aftermarket coolers as well, though, are comparable to this, maybe slightly better. And you know, that's what most computers will actually come with, especially if you order PCs that are from sort of the larger manufacturers like Dell and HP and Lenovo and that
Hold
sort
on.
of thing.
I just noticed something.
Yeah.
So wait, so it takes up, like I literally just noticed this now, it takes up this much height vertically, but I only just noticed that like how much of this is plastic. The heatsink is only that much of it.
That is actually so true.
Anyway, continue. So what do we use?
And I mean, you can see the copper underneath over there. So this over here, that we use in our Vulcans, just as a sort of size comparison, this is our Noctua cooler. So, I mean, what else do I need to say?
Oh, absolutely amazing.
And this is actually, doesn't have the other fan on, so...
Yeah, so it's got two, how big are those fans?
It's 140mm fans.
Okay, times 2. And this one over here has what, like a 92?
Yeah, I think around about there.
Oh, okay.
So, I mean, you can see...
And, okay, wait, so then how does the cooling actually, like, affect things?
So, all else equal, if you had to take the exact same CPU, keep the settings in the BIOS exactly the same, no modifications, adding this cooler to most CPUs will make it run faster. So, built into most motherboards and CPUs nowadays is sensors to make sure that the CPU is running within thermal spec. When you start exceeding that spec, then it will actually reduce the frequency of the processor and as a result reduce heat. And we've seen stock Intel CPUs with a stock cooler actually hitting its thermal limits. Yeah, you're basically then paying for something, expecting a certain speed, and getting something else. I mean, this would probably cool the non-K CPUs fine.
Yeah, that's why it comes with the non-Ks.
Exactly, yeah. It's relatively loud as well, so that's another thing I was going to mention is because of the size, it needs to spin at a higher RPM as compared to the 140mm fans, which move a lot more air at a much lower RPM.
I've actually seen cases where people were using sort of the aftermarket version of this. It's essentially a stock cooler that you buy separately on an Intel i9-12900K. At stock values, the i9-12900K like hits its limits, doesn't it?
Yeah. Even with some aftermarket coolers, if you keep the 12900K stock, you just turn it on and get going, it'll sit in the 90s and start hitting its thermal limits. All things equal, this will not only have the CPU running at its highest rated speeds, it'll also be doing it at the near 0 decibel levels. So
it's imperceptible to the human ear.
Yeah,
in my opinion.
for sure.
Is it only K CPUs that can be overclocked?
No. So if you have the right motherboard, then you can actually overclock a non-K CPU as well. We overclock that using BCLK overclocking.
Yeah.
We actually had one the other day, i7, and it left our offices here at running at over 5.1 gigahertz.
Incredible.
Yeah. So
and what's the stock on that?
4.9, and that's 4.9 on maybe 1 or 2 cores, whereas we're talking about an all core overclock.
Oh yeah.
So that's another good point as well. Actually, if you think about the advertised specs, if they say that the CPU runs at 5.3 gigahertz. That's only on 1 or 2 cores in the perfect environment, at the right temperature, etc. What we do is we optimize on a per core basis, and then that'll obviously mean a higher frequency for every core.
Yeah. I was actually thinking about the i5-12400. When we overclocked this i5 non-K, we were getting better performance than we were from like AMD Ryzen 7 5800X.
Yeah. Yeah,
it's absolutely crazy, and of course, like we said, it does require very particular hardware. In the country, there's only one model of motherboard that supports this kind of overclocking.
Yeah.
So what do you think goes into a good motherboard for overclocking? Because I mean, is it just any Z motherboard or this particular B motherboard? What do you think?
Yeah, so that's once again where our expertise comes in, where you can you can go and pick any Z motherboard off the shelf and stick in a a K Intel CPU and overclock it. But yeah, there's a lot more that goes into it, like VRM cooling. So as you increase the frequency, and as a result the voltage of the CPU and the voltage that the CPU gets, not only will the CPU temperature increase, but it's the VRMs that are delivering power to the CPU which also increases. And we've seen the latest 12900K i9 hitting 90 odd degrees on weaker VRMs, which will not only cause instability, it'll actually, in our testing where we push the limits, it just completely shuts the PC. Yeah, just completely shuts the PC down. But with the motherboards that we use that get sent out to customers in our builds, there are proper heat sinks on the VRMs.
Yeah, absolutely massive, like really, really thick heat sinks. They've also, we of course do look into the power phases of each motherboard that we get in, and we've done pretty extensive testing on these. Okay, so the main point of this is, how does this apply to workstations specifically? Why would we want to overclock? What kind of performance gains can we see, and what software sees these benefits?
So pretty much any software package that benefits from a faster CPU, or if we're talking about GPU overclocking as well, a faster GPU will benefit from overclocking. So all you're doing is you're giving the CPU a better environment in which to operate, which allows it then to increase its speed. You'd obviously do that manually. It will do it by itself up to a certain point, Intel's limits, but with overclocking, that's what you're doing. You're increasing those limits. And the software should run better, should run faster. Renders will be completed quicker. Simulations will be done quicker. Opening models will be faster. There really are no downsides if done properly, with the right cooling and everything, like I mentioned.
Yeah.
There are no downsides to overclocking, and no perceptible level of degradation to the CPU silicon.
Yes.
Or GPU, depending on what you're overclocking, RAM even. It's a no-brainer in our opinion.
Absolutely. The CPU itself, it's not like it's inherently naturally made to only run at this speed. Basically, the ones that go out to market are the ones that meet the standards to run at this speed, but that doesn't mean they can't go any higher. You mentioned something very interesting there, Intel doing it by themselves and like automatic stuff. And I understand, AMD does that as well. Since it is overclocked already to a certain degree, is there really a perceptible difference over that when you overclock manually versus just letting the computer do its thing?
There is. So what the likes of AMD and Intel will do is the power limits that they would apply would be extremely conservative. And it would be sort of a worst case scenario with regards to the cooler that the customer might install on the CPU. So because we know what cooler we are installing and we know what changes we're going to make, we can overclock every CPU, which, like you mentioned, is unique. GPU as well. It's unique in the way the silicon is made, the CPU is made, graphics card. So we're able to extract every possible megahertz out of any given piece of silicon. It obviously takes more time, but for that time spent, you get a higher quality, more reliable, faster workstation.
Absolutely. And okay, so the kind of software that we've overclocked for, especially it's, because the kind of software that we overclock for, it's been things like Revit, Inventor, Twinmotion,
Photoshop.
Oh yeah, that's
Adobe
right. Yeah.
Premiere, yeah.
DaVinci Resolve as well.
Yeah.
And so we definitely have seen gains in performance, not just in single core performance, but also in multi-threaded performance as well.
Yeah, absolutely. If you are rendering a video at 30 FPS and it takes you, let's say, depending on the program using quality, etc. For argument's sake, let's say it takes you 5 minutes a frame. If you are saving a minute because of overclocking, if you're doing 30 frames per second, and you are then doing, maybe a 10-minute clip, that's literal hours of time saved.
Yeah, this is the benefits of having people like us who are like enthusiasts as well as software specialists, because we get to combine that knowledge and things, understanding stuff that we use in our hobbies and things to get better performance for our own just enjoyment, and being able to transfer that knowledge into a workstation PC so that we can get the best of both, stability and reliability as well as performance.
Yeah, absolutely. Because we're speaking to a different type of customer. Although we do sell to gamers, we focus on the professional, and for them, stability is number one. Very rarely will a customer come to us and say, it can crash now and again. I just want it to be absolutely, when it does work, as fast as anything. Which, I don't know if anybody said those exact words to you, but they haven't to me. And so we place a lot of emphasis on reliability first and foremost, and then when we are overclocking, keeping cognizance of that while extracting performance.
Yeah. So generally what this means is that we don't overclock to the absolute maximum that the CPU can handle.
Yep.
We do figure out what that is and things, but we do get the maximum stable overclock.
No, for sure. We could quite easily, overclock whichever component even further, which would, hit some great benchmark scores and, maybe complete a render slightly quicker, but we don't want to have that render complete 8 times out of 10.
Exactly.
We want 10 out of 10 completion and stability. It's a non-negotiable for us. And
exactly.
Especially the type of work some of our customers do, that simulation failing in the middle of the night, maybe got a deliverable the next day to a customer that can cost them tens of thousands of rands. So we always keep that in mind.
One great use of these coolers is that since you're not going to be using it in the system, you get a really cool spinning cup holder. Okay, so it was great talking about this kind of stuff and how overclocking fits into the workplace. Now, this is not going to be the end of us discussing overclocking. This is, in fact, just the beginning. What's going to happen next is that in future videos, we are going to be showing benchmarks of before and afters of overclocks in particular software. So we're going to be showing how overclocking certain components can give you better performance in Revit, in Twinmotion, in Inventor, in DaVinci Resolve, all of these kinds of things, and in the particular processes that it benefits in as well. So we're not just going to say, oh, it's better for Inventor or it's better for DaVinci Resolve. We're going to show how much quicker it does rendering and how much faster it does like particular things. So I'm quite excited to get some data on that, and it'll be really interesting to pinpoint exactly where things are.
Yeah, looking forward to it as well. Now we've got a good number of benchmarks that we've already run, and we're obviously doing the before and after testing in this specific PC we've built for this testing. So it'll be interesting to share the results.
Thanks so much, Damian.
Cool. Later.